Hi there. This time we're going to talk a little bit more about nuclear radiation and more of applications of nuclear radiation. So we've got a few key ideas. Where are we exposed to radiation? What are some beneficial uses of nuclear radiation? What factors determine the risks of nuclear radiation? How is the energy produced by nuclear fission used? So starting looking at the first question, where are we exposed to radiation? So we're continually exposed to radiation from natural sources like the sun, but also from soil, rocks, and plants. We do get something called background radiation. So we define that as the nuclear radiation that arises naturally from cosmic rays and from radioactive isotopes in soil and air. Radiation is measured in units of RIMS. So we can define RIM as the quantity of ionizing radiation that does as much damage to human tissue as 1 Röntgen of high voltage X-ray does. I'm surprised they don't capitalize Röntgen here. This is the individual who first was able to utilize and discover X-rays. So this is a German scientist who did so. Exposure varies from one location to another. Some activities add to the amount of nuclear radiation exposure. So we've got some different radiation charts here. Radiation exposure per location. So this is millirims per year. You can see that Tampa, Florida is 63, but comparing that to, say, Denver, Colorado is 164. And I would say that this is more connected to perhaps solar radiation. I mean, that's going to be where most of your radiation exposure comes from. And we can talk about the elevation difference between Florida and Denver, Colorado. Denver is quite a bit higher elevation, so there's less atmosphere between you and the sun in Denver, Colorado than there is in Tampa, Florida. Now, the temperature difference is different, though. Radiation exposure per activity. You can see smoking, 1.5 packs per day, exposes us to 8,000 millirims per year. I mean, look at the comparison from the sun compared to cigarettes. Gross. Flying for 720 hours, so if you work in an airline. Inhalation of radon from the environment. Receiving medical x-rays, so that's very low risk. Now, if you work in that environment all day, every day, then you're going to take more precautions than if you just go for an x-ray every once in a while. And even if you do that, they still give you the lead vest to put on your chest and body usually. And what happens is lead is a very good shield against radiation. So what are some beneficial uses of nuclear radiation? Some common applications of nuclear radiation include medical diagnosis and treatment, smoke detectors, manufacturing, and agriculture. Smoke detectors help to save lives. So we have alpha particles that produce an electric current within smoke detectors. And smoke particles in the air reduce the flow of current. So when these alpha particles, or this current between these alpha particles is actually reduced because of smoke, then the alarm goes off because of the current difference, or there's a change in that current. Nuclear radiation is used to detect diseases. We use something called a radioactive tracer, a radioactive material that is added to a substance so that its distribution can be detected later. Nuclear radiation therapy is used to treat cancer. We call this radiotherapy. Treatment that uses controlled doses of nuclear radiation for treating diseases such as cancer. Agriculture uses radioactive tracers and radioactive isotopes as well. Alright, so what factors determine the risk of nuclear radiation? The risk of damage from nuclear radiation depends on both the type and the amount of radiation that you're exposed to. Nuclear radiation can ionize molecules. So ionization is a change in the number of electrons in an atom or molecule. Cancers associated with high dose exposure include leukemia and breast, lung, and stomach cancers. High levels of nuclear radiation can cause radiation sickness. So radiation sickness is an illness that results from excessive exposure to nuclear radiation. So people that work in radioactive areas tend to wear a dosimer. A dosimer is a device that measures the amount of radiation exposure. High concentrations of radon gas can be hazardous as well. Radon gas is colorless and odorless. It's produced by the decay of uranium-238 that's just present in natural soil and rock. Radon gas emits alpha and beta particles and gamma rays. And then we do have tests for radon gas that are widely available. The buildup of radon gas is common in basements. So you want to make sure that you get your basement tested. It can occur in other levels of the house, but typically in other levels of the house there's more air circulation, so the radon is able to escape. So a fix for radon gas buildup is to have a well-ventilated area. And this does happen or does occur in our area as well. So make sure you get your house tested. The other question here, how is the energy produced by nuclear fission? Energy produced from fission is used to provide electrical energy to millions of homes and businesses. Nuclear fission has both advantages and disadvantages. So it does not produce gaseous pollutants, so that would be an advantage. There's much more energy in known uranium reserves than known reserves of coal and oil, so it sounds like an advantage as well. Radioactive products of fission must be handled carefully, so a disadvantage. Nuclear reactor must be equipped with many safety features. I guess just a precaution. I guess this could be considered a disadvantage. Nuclear power plants are expensive to build. Disadvantage. Nuclear waste must be safely stored. So what do we do with the waste is also another disadvantage. Nuclear fusion releases large quantities of energy. The hydrogen fusion reaction itself releases very little waste or pollution. So it's not the reaction itself that's a problem, it's what to do with the substance that remains after all nuclear reactions have ceased to continue. These reactions are difficult to produce in a laboratory because of the amount of energy that's typically required to initiate these, and then how much energy is released from this reaction. So controlling this reaction once it's started is also a potential issue. Nuclear fusion also has advantages and disadvantages. So fuel for fusion is abundant. The expense of operating a fusion power plant would be high, just to name a couple. So that's all I've got for right now. So thanks for listening.